Good afternoon everyone and welcome. My name is Oliver Thompson. I'm your host for today's webinar on wine proficiency testing. Thank you for joining us today for what will be an interesting and useful introduction to the first advanced wine proficiency test offered by Fera Science. Our webinar is scheduled to run for 45 minutes. Our speaker will begin the presentation shortly, and during the course of the webinar we'd like to invite you all to submit questions via the chat dialog that should be visible at the bottom right portion of your webinar display panel. We will have an opportunity to answer some of your questions at the end of the presentation, and we'll try to get through as many as possible, time permitting. A recording of today's webinar will be available to you all shortly after this event, and we will notify you on how to access this as soon as it becomes available. The topic of this webinar is concerned with a new panel of wine proficiency tests offered by Fera Science. The consumption and production of wines continues to grow around the world, and mature European wine markets are showing steady growth alongside new emerging markets in Asia. The global market for food testing services is projected to undergo enormous growth in the next few years, accompanied by increasing standards for food quality and regulation of these standards. In addition, consumer awareness of food safety, authenticity, and effects on health is driving demand for thorough and reproducible testing of food products. Maintaining consumer confidence in the quality and fidelity of wines will be critical for the projected market growth of these products. It's my pleasure to introduce today's speaker, Mark Sykes. Mark has been a senior scientist at Fera Science for over 20 years and is the scientific advisor to proficiency testing, responsible for overseeing the scientific integrity of all proficiency testing services. Mark's background and experience is in analytical chemistry, in particular mass spectrometry, and his expertise includes techniques essential for robust food testing procedures. Mark has an extensive record of peer-reviewed science and is active in the scientific community, publishing his work on proficiency testing data and speaking at international conferences and workshops. He is also the Fapas representative for the UK Proficiency Testing Working Group. So now I'd like to hand over to Mark and look forward to an interesting and useful session.
Thank you very much for that introduction, Oliver. So today's presentation is about the recent wine proficiency test that Fapas has run, and I'll be describing a bit about the background of this proficiency test, why we were running it, the outcome of the first proficiency test, which was reported to participants just 2 weeks ago, and what we have for the future in terms of extending this scheme of proficiency tests and how we might improve it. Let's start with a little bit of background context and why would we have such a proficiency test. Wine is now very much a global commodity. It's traded across countries, in fact across continents, and there is a need to recognise the analytical data produced by different laboratories regardless of their different associations. So, for example, one of the issues that has been highlighted is that an exporter's laboratory might produce a set of data and that might disagree with the laboratory data of the same wine for an importer. So how do we trust which laboratory is producing the valid data? So this new series of proficiency tests was very much a collaborative exercise, and there was a goal, a target, which principally was about education. So for us as a proficiency testing provider, we needed to understand more about this sector of wine analysis and how we can apply proficiency testing to it. We also needed to understand more about wine analysis itself, and this is quite a complex industry. And for the wine industry stakeholders, it's about demonstrating what is best practice for the industry and what can we learn from this exercise. Accreditation is an important part of this exercise, particularly for the laboratories, but also as a proficiency testing provider and our own accreditation. And in terms of collaboration, we liaised initially with our agent in Italy, Star Ecotronics, and we held stakeholder meetings both in Italy and the UK. The idea of the proficiency test itself was initiated by Fedivini, which is the Italian Wine Federation, and we had technical support from ISVIA, which is the Italian Reference Laboratory for Wine. So let's put into context the international standards, and in particular 17025, which is the ISO standard for laboratory methods, which many of our participants will be familiar with. This was revised and published last year, and it has a greater emphasis on proficiency testing. So clause 7.7 is about ensuring the validity of analytical results, and that laboratories shall have a procedure for monitoring how valid these results are, but also, importantly, that it shall be a planned exercise and shall include, but not necessarily be limited to, participation in proficiency testing or similar inter-laboratory comparisons. So there is very much an international standard basis for proficiency testing and the requirement for laboratories to take part. Proficiency testing for wine is not a new concept. There are existing wine proficiency tests and even ones run by Fapas. So we have run proficiency tests for a number of years, but they've been rather limited in scope, and these didn't quite meet the requirements that were being set out for the new proficiency test. So for example, we had a few heavy metals and some quality parameters that would typically be measured for labelling purposes and legislation purposes, these being alcoholic strength and sulfur dioxide, and one or two other contaminants such as ochratoxin A. These are small in scope in terms of the number of analytes, and the actual sample size is also small, intended just for those analytes of interest. But nevertheless, we had a long history of providing these types of PT. So what about the new wine PTs? How are they different? Well, for a start, we have 3 samples, not just one. There is a red wine, a white wine, and a challenge wine. That is one which we didn't identify in advance. the size of the samples was much larger. So each of the wine samples was a total of 1 litre, made up of 4 different samples of 250 ml each. But the main difference was the number of parameters. This was 61 parameters in total, covering not just the quality parameters and the few heavy metals that we had before, but also some of the chemical congeners that are produced during manufacture, some of the sugars and organic acids, as well as inorganic ions, and some quality parameters, for example to do with colour, and an extended range of elements and heavy metals, as well as 1 or 2 parameters associated with authenticity. So this was a considerably large challenge and unprecedented in what we've attempted before in a single proficiency test. The operation of the PT followed our standard mechanism of PTs. So we started with setting up our website to enable online reporting of results and registration for participants. We commissioned the test material preparation. The PT itself started on the 27th of March this year, and we initially had a 4-week window in which participants would analyse and submit results. However, it became very clear that because of the scale of this PT, we needed to extend the submission date, and so the close of this PT in the end was the 8th of May. We then spent considerable time analysing all the data that came in, and the report was drafted and discussed at a meeting with Fedivini representatives here at York in early June. The final report was substantial. It was a 300-page report, and this was published on our website in the middle of June, just 2 weeks ago. So this is a very appropriate time to be discussing the outcome of that report, not just with the participants, but with the wider analytical community involved in the wine industry. The test materials were provided from a production line of wine in the kind of container that would be associated with the purchase of wine. So an important question to ask is, how could we ensure the homogeneity of these samples and that all the participants were receiving effectively the same sample? It would not be practical or cost effective to analyse for every parameter in every sample to achieve this. Therefore, we agreed a low risk, evidence-based assessment of homogeneity based on what we know about the preparation of the sample and also what we know about historic homogeneity data of Fapas samples. These are liquids, so they are inherently homogeneous. The data on this slide shows what we assess in homogeneity in terms of both analytical variance and sample variance. In both cases, we generate statistical data, so this is the SAN over SP for the analytical variance, or the SAM squared data for the sample variance. How we generate these statistics is not something I can go into in this short presentation, but the important point is that we are comparing the statistical values against the critical values, and in all cases the statistics are less than the critical values, which gives us a high degree of confidence that the test materials would be homogeneous and that the exercise is a very low risk in terms of inhomogeneity between samples. The other valid question to ask, particularly for wine, is the risk of stability. There are certain parameters which we know carry a risk of being not stable. These are typically the volatile parameters, sulfur dioxide, some of the volatile acids, which would be measured as volatile acidity, and the alcohol volume itself. So we carried out experimental data for these parameters over the course of the PT, and in fact extended beyond the date of the PT. So in the graphs that you're looking at here, the x-axis is the number of days, and the experiment ran for nearly 90 days, that's about 3 months, where day 0 was the day of preparation of the samples, and day 90 well beyond the end of the proficiency test. For sulfur dioxide, both free and total, you can see that there is a slight downward trend of the graph. But in fact, when you look at the statistical property of that trend, it's a very small degree of degradation, and it would have no effect on the outcome of the assessment of the assigned values. For volatile acidity and alcohol volume, there is clearly no issue at all about stability within these samples. So what did we learn from this proficiency test? There were some key successes, which I will describe. In addition to this, we had 73% of participants returning results. This is not unusual for a new proficiency test, so actually very promising. Most participants analysed only for selected parameters, so the scope of the proficiency test was perhaps too wide-ranging. The data analysis was comprehensive and according to our standard Fapas protocol, which many of our participants will be familiar with. Many analytes had insufficient numbers of results to assess. One of the questions we asked all participants at result submission was about their limit of quantitation and their recovery data, but in fact very few participants submitted this information. As I've described, there was no evidence of instability either through the formal stability testing or in fact from evidence in the PT data itself. There is also no evidence of major method dependency, and I will describe some examples of that in detail. There were clearly some very difficult analyses. So the key successes, the key parameters of the quality of the wine were well reported with high success rates. That is to say, participants managed these analyses very well. So these were typically the alcoholic strength, some of the congeners such as ethanol, the acidity, the total sugars, one or two of the organic acids, the total sulfur dioxide, and some of the heavy metals. These were all well reported, and the assessments show that the labs perform extremely well. So this is very promising. How do we define successful for those of us not familiar with the outcome of a proficiency test? Well, this is one example. It's the pH in one of the samples, the white wine, and you can see that the distribution of Z-scores is centered around 0. It's a symmetrical distribution, and the majority of participants have Z-scores within the +2 and -2 tram lines. That's a target standard deviation limit that we apply for the performance purposes of a PT. There's a couple of labs to the right hand side, lab 6 and 32, that have performed not so well. So they have Z-scores outside of that limit. But it's only a couple of labs, and in fact one of those has achieved a Z-score less than 3, so that one might simply be a statistical anomaly. So this is what a good set of data looks like. At first glance, this set of data looks a bit odd. There's clearly a subset of labs to the right hand side of each distribution here that appear to be doing very differently to the majority of labs that are very close to a Z-score of 0. So what's going on here? This is the parameter of volumic mass at a defined temperature, 20 degrees C. The interesting thing here is that all three test materials show the same trend. So that is, a majority of labs have the same result with a Z-score of 0, and to the right hand side that subset of labs doing something different. This is therefore a systematic bias in this dataset. Does this mean that there's a problem with the sample, or does this mean there's a problem with a method parameter? If we look closely, we see that the subset of labs that have the different result is in fact the same subset of labs for all three test materials. Therefore, these labs are doing something different to all the other labs. It's not sample related, it might be method related, but we do not have the information about what those labs are doing differently to help us understand this. So this will be an improvement for a future PT to address. Nevertheless, this is a successful outcome because it's identified a problem. What about the challenges, the things that have not gone so well? Test material C was a challenge wine. In fact, it was a blend of red wines. But for some parameters, the ones that we've got on this slide of total sugars, the sum of glucose and fructose, and the malic acid, these were not well reported, and the assessments were not very satisfactory for these parameters, but only in this test sample. This effect was not observed in the other 2 wine samples for these parameters, which were well reported and well performed. So test material C indeed was a challenge analytically for the labs taking part. Again, we don't really understand why this was a challenge, but it shows that different wine samples will give different outcomes for laboratories. Some parameters we issued for information only. This is to say that we should not rely too much on the outcome of the proficiency test in terms of lab performance. 2 of these parameters are highlighted here on this slide of total polyphenols and carbon dioxide. Why would we give information only assessments? The reason is the uncertainty of the assigned value. So if we compare the uncertainty values that are tabulated here against the standard deviation for proficiency, sigma p, we can see that the uncertainties are very similar, if not exceeding, the values of sigma p. Ideally, to issue performance scores, the ratio of U to sigma p should be less than 3. If that is the case, all is okay. But the ratio here clearly exceeds 3, so we cannot issue Z-scores. However, these 2 parameters we knew would not be within the scope of accreditation as a PT provider, but nevertheless they are useful outputs for educational purposes for this PT. Therefore, we made the decision that it was worthwhile issuing the assessments, but for information only, to give more interest to the outcome of this PT. Clearly, more work is needed to understand why this is happening. The alcoholic strength, on first glance at the data, we only have 70 or 80% of labs achieving Z-scores within the satisfactory range of plus or minus 2. This might be of concern. Surely alcoholic strength is a fundamental measurement for wine, and labs should be getting this correct, with a high proportion of labs doing well. We see that the alcoholic strength was divided into 2 parameters, real and apparent. The real alcoholic strength is for direct methods, for example distillation, and the apparent alcoholic strength is for indirect methods, typically a density measurement. So is this of concern? Well, if we look at the Fapas data over many years for alcoholic strength in wine, in fact we only get about 75% overall of Z-scores within plus or minus 2. So in fact the outcome of this new proficiency test is perfectly normal compared to historic data. If it's not good enough, if it's not fit for purpose, then we need to re-evaluate what it is that laboratories are doing in producing these values for alcoholic strength. The sulfate was another challenge. So if we look at the tabulated values here for total sulfate as potassium sulfate in all 3 test materials, these were issued for information only and with a low percentage of satisfactory Z-scores, 57 to 64%. and fewer than half the participants in the proficiency test submitted data for this parameter. So it was not well reported and labs didn't perform that well. What about the free sulfur dioxide? You can see here on the charts below the table for 3 test materials the distribution of the data for free sulfur dioxide. These also were not well reported by labs. However, in this case, it's clearly not method related and not sample related, and the interpretation, the conclusion that we come to, is because the 3 distributions are different. So test material A is skewed to the left, test material B is clearly bimodal, test material C is skewed to the right. There is no pattern, no trend here. This contrasts with total sulfur dioxide, which was well reported and performance was good. How do we know about method dependency? What can we do in a proficiency test dataset to investigate this? The example on the slide here dates back a couple of years to a historic Fapas PT which was bimodal, and I've identified where the modes fit on the data distribution. So there was a mode at 12.62 and a mode at 13.12. These are 2 distinct populations of data with similar errors, so they are very similar sets of information. There are also extreme values to the left hand side, and in investigating this particular data set, lab 19 and 38 were actually the same lab submitting 2 results. They were not accredited for this parameter, which again is alcoholic volume, and they used distillation. Lab 35 and 40, in that same group on the left hand side, we don't know what methods they used. They didn't submit method information. Therefore, there is a certain amount of work we can do in investigating methods, but if labs don't submit that method information, then we can't do such an investigation. So, to determine whether or not there is method dependency, we need certain things. A lot of data helps. So small amounts of data are limited in their statistical power. It's better to use repeated exercises. A single proficiency test on its own is okay, but in terms of trend analysis, it's limited. We require participants to submit accurate method parameter information. Once we have that, then we can do a statistical data analysis and investigate method parameter dependency. So we are asking 2 questions. Is there an observable multimodality, and can we attribute those individual populations to a specific method parameter? We have experience of doing this in the past. There are various Fapas publications in the scientific literature on this, and yes, we can do this for vitamins and allergens, but also we can demonstrate a lack of method dependency, and we have publications on this for sodium analysis, HMF in honey, and PAHs, so it can work both ways. What about the future? We want more international participation. this is not a closed series of PTs, it's open to any laboratory worldwide. Clearly there is a targeted analytical interest. 61 parameters is a lot for any one laboratory, so we want to make sure it's applicable to as many different laboratories as possible. We also are in discussion with our stakeholders about more PTs covering different areas. This is authenticity for geographic authenticity, pesticide residues, and microbiology. These we want to attempt next year. We also want to use these PTs to generate reference materials. What is different about a reference material? It's about accuracy rather than precision. So with a reference material, we would provide the reference values with the measurement and certainty of that reference value. This gives us a measure of accuracy. It's not the same as the standard deviation for proficiency, which is a measure of performance precision. And on the histogram here, this demonstrates the difference where you have plus and minus 2 sigma p's, that is the performance precision of the PT, but the uncertainty of the reference value is a much smaller variance or measure of variance than the performance precision, and this gives you a better understanding of the accuracy of your method against a reference value. So, in summary, this is a very promising start to this new set of wine PTs. There are improvements to be made in terms of target analytes and better understanding methods being used by participants. We have now produced QC samples from the remaining test materials, and datasheets are available now on the Fapas website, and this slide gives you the product code to search. You can find it quite easily. And future PTs next year will be extending the scope of what we're doing. A few acknowledgements. So Giovanna Lampis of Star Ecotronics, our agent in Italy, who set up the negotiation with the stakeholders. Francesco Pavanelli of the Italian Wine Federation Fedovini, whose idea this was in the first place. Glenn Prantedu at ISFIA, which is the wine reference laboratory in Italy. We thank him for his technical expertise and advice in setting up this PT. And finally, to my colleagues in Fapas, who did most of the work in terms of statistical analysis and the writing of that report. So we have a few minutes left to answer some of the questions that have been coming in, and for more information visit the website fapas.com, and the next PT is already scheduled. You can see the PT reference number 1388 and its product code. You can just use those directly on the Fapas website. The dispatch date is the 19th of October this year, and thank you for your time.
Well, thank you very much, Mark, for a very thorough and interesting description of the new PT testing that you've been developing here at Fera Science. So we have a few questions that have come in. First of all, this question is, this PT was described in the report as not accredited. Will future proficiency tests be accredited?
Yes, thank you for that question. So the report, in the end, we decided that we could not claim as fully accredited as a PT provider. The reason for this was simply the scope of what we were attempting. So some of the parameters would fit within our schedule of accreditation, some clearly would not, and we would need to apply for extension of scope. So we made the cautious decision to not claim accreditation on this one, but to apply for extension to scope for the future PTs. But we do assure our participants that despite this, we followed all our usual procedures for what would ordinarily be an accredited PT, and our participants hopefully are already familiar with the quality standard that we apply to our normal proficiency test products.
Our next questioner says, I took part in the recent wine proficiency test, and for some parameters there was no assessment. How will you address this in the future?
Yes, so thank you to that attendee who's sent us that question. It's very relevant, and in fact it's relevant to proficiency testing in general, not just this particular one. The assessments in a proficiency test are dependent entirely on the data that we receive from the participants. In statistical terms, the more data points we have for our calculations, the more powerful is that statistical process. So where we've not been able to assess parameters, it's been because of a lack of sufficient data. So we encourage participants that are existing participants to attempt to submit for as many parameters as possible, and in fact if we can open up this proficiency test to yet more laboratories and they can submit their data, that is all to the good, and it will only enhance the educational purpose of this PT. So please do submit more data for the next PTs.
In your description of the recent PT, you mentioned the use of white wines, red wines, and a mixed challenge wine in that instance. Will future wine proficiency tests indicate a sparkling wine, include a sparkling wine, and for which analytes?
Yes, so those of you who are particularly observant in that long list of parameters that was on an earlier slide, there was one parameter which is overpressure. Now this is specific to a sparkling wine, and because sparkling wine has carbon dioxide with a gas pressure above the level of the liquid, this is effectively the measure of overpressure, which applies only to sparkling wine and not to still wines. Now, we didn't include sparkling wine in this PT, so we made it clear in the instructions to participants that overpressure would not be required. However, we did include it for the purposes of completeness for future proficiency tests, which would be intended to include a sparkling wine in future.
Well, in the interests of time, I'm afraid we're going to have to wrap up the webinar for today, but I'd just like to finish by thanking you once again, Mark, for such an interesting and thorough discussion of the testing here at Fera Science. And I'd also like to thank everybody who's logged in and participated in today's webinar. So if you would like more information on this subject, please do visit the Fapas website at www.fapas.com. And as I said in the introduction, we will be releasing this webinar to be reviewed once again, and you will all receive notification when the webinar becomes available. So once again, thank you very much for joining us today.